code page. So today I will write asynchronous up counter 2-bit without using common clock. Okay. My screen is clear. You can see it carefully or not? I think it is visible.
Yes, sir.
Okay. So as you know that when I talk about asynchronous up counter, then definitely there is no common clock. So I will write the code for VHDL code today. Okay. The thing is that how to write VHDL code for 2-bit. Okay, not more than that. So 2-bit asynchronous up counter, that I will write today. In the previous class I have written for synchronous up counter 2-bit. Today I will write for asynchronous up counter where clock is not common. Okay. Now, so the thing is that in the previous class, as there is a common clock, so I did not to take about any signal or any numeric thing. But here I need to take numeric. Okay, rising edge. So that part I need to take. Therefore, in the library, I will just take library IEEE and the standard logic use IEEE dot standard logic, then 1164 dot all, and numeric you have to take. So use, this is another thing you have to take, and I have solved one similar example where you need to consider the numeric, because now I will be considering that one, that the basically up count down count. For that I need that. Okay, so IEEE dot numeric and standard dot all. So this is the library declaration. Now next, what you have to do, you have to declare the entity part. So entity, so asynchronous counter. So let us say AC, okay, is asynchronous counter is, then port. So what are the port? X, first of all, X is the input and which is standard logic. So that will be similar like the previous example. And you also need a clock for the first one. So here I will write in, it is also standard logic. For the first flip flop I need some clock. Then Q is the output, which is a in out variable. Okay, so in out, and then there is a change. Okay, so because I will write for the asynchronous counter, so clock is not common, so I have to depend upon this Q, which is the in out. So you can see this, let us say I have one flip flop, I have another flip flop. Now if you put a clock here, so the output of the next will be output, as well as it will be a input for the next flip flop. Okay, so that's why I need basically an in out signal. And here see the numeric standard I am using. So in out I will write signed, because it will define whether I will go for up count or down count. Signed 1 down to, and why 1 down to I am writing, because it's a 2-bit. I am writing for 2-bit asynchronous counter. If I am writing for 4-bit or 3-bit, sorry 4-bit, then I have to write 3 down to 0. If it is for 8-bit, so 7 down to 0. So I am writing 2-bit, that's why I will write 1 down to 0. And an initial value, definitely initial value is 0. So this is the extra thing that you need to, already I have solved this type of problem, but this is kind of a repetition. Now output, finally you need a output. So when a count is completed, you need to put the output. So it is basically an output standard logic, like the earlier day that you did in for synchronous counter. Here also we have output, which is the output standard logic, and initial value. What is the initial value? Initial value is 0. So this is your port definition. Okay, how these are the port which is required. Now end, right, end the asynchronous counter. Okay, this section is complete. Now next I will go for architecture. So architecture, that definitely you can understand that the architecture will be behavioral model. So architecture, behavioral of asynchronous AC is, so this is asynchronous and I am using behavioral model. Now I have to do first of all begin, and then anyone, then process clock, and once again begin. So after that, what things I need to check? So see, the clock is moving. Let me go to the diagram. See, this clock is moving, so I have to take for rising edge or falling edge. So first I will check rising edge clock. So I will write if rising edge clock, then what? Then I have to go for the check whether the x input, this is the x. So I already have considered whether the clock is going for the rising edge or not. If it is a rising edge, then I need to look into the value of x. Okay, so now if x equal to 1, now here if x is equal to 1, then what I have to write? Then q. Okay, so basically then this is the your output. Okay, and what I have to write? Q0. Okay, what will be the output? Anyone? 0 and then 2 bit na, so I
One.
will 1 1. So what will be the output? That is the q. So what I will write? So there has to be toggle. Toggle means if the initial value already I have given, the initial value is 0 0. So the next thing is what you want, it should go to the next value. That means you considering is this q0 and let us say q1. Okay. So if this is 0 0, the previous value, so next value will be up count. That means 0 1, and then that will be 1 0, and then finally it will be 1 1. Okay. So you see there is a transition from 0 to 1 if you have a rising edge clock at the input. Okay, and definitely x value has to be equal to 1. Okay, so x is 1, rising edge is happening, the definitely this q0, the first bit, there has to be some change. Okay, so what I will write here, so q0 now, and q, why q0 I am taking? Because I am taking it is for a vector. Okay, 1 down to 0, it is basically vector. So when I will write q0, that means the LSB part I am writing. So q0 is the LSB is equals to not of u0. Okay, so this q0 is the previous value. Okay, and from where I am getting the previous value, I have already declared 0 0 is the initial value. Okay, q0 and this is q1, initial value is 0. So what I will do now, so this is your next value. Okay, this is the next. So next value is equal to not of q, that means 0 bar equal to 1. So 1 is the value of q0. Okay, now end if. So end if. Then what I need to check? So this thing will continue. Okay, so 0 0, then 0 1, then 1 0, then 1 1. You see every time this is toggling. Okay, 0 to 1, then 1 to 0, then 0 to 1. Okay, so this line is appropriate for all. Now next I have to check that, okay, so if x equal to 1, that part I have done, so x is equal to end if. So that comma I have, semicolon I have to give. Now end if I have given. So if I have to once again check if the q value, let us say by doing that, if q, the final value, if it is equal to 1 1, finally you are reaching to this particular state 1 1. Okay, then what you have to do, then what will be the output? Then output definitely you have to assign to 1, else output should be assigned as 0. And then end if, this if I am ending here, end if, and then end if, then this end I am doing this, so that means end if, and first if I have taken rising edge, so end if. So this is the rising edge if I have started, so I have to finish it. So in end if, let me check the if first. So if rising edge, it is this if is completed, this if is also completed, so first if is not completed, so end if. Okay, now next, end process. Okay, so you tell me that the program what I have written now, whether the program is completed or it is not.
So
So we don't
report
have the
falling edge,
clock
sir.
input, right?
Falling edge also important.
See, this is actually not completed. Okay, the program what I have written, it is not completed, because you see I have processed with the q0, this part I have processed. Okay, but what about this q1? Q1 is not maintaining that. Q1 is 0 0 here, then it is 1 1. So I cannot say it is just not get. So what I will do here, I will process, okay, because q0 change is already there. So q0 is initially 0, then 1, then 0, then 1. This value I am getting, okay. So now I can process this variable now, because already your program, first program is complete. So see, this program what you have written, this program can give 0 1 0 1, okay, for the q value. So once you have this value, then you can start another process. So I will write here process q of 0. This is the next, the present state value. Okay, and you see as it is asynchronous, that's why I have to write this. Otherwise in clock, in if it is synchronous, then this type of thing is not required. So as it is asynchronous, that means the q0 will not going to decide what will be the value of q1. Okay, so this is a problematic thing, because you do not have any clock control. So for that you need to have this value first. So what I have done for the first programming, I know that q0 in the present state I can change based on the current event, okay, or previous event, that I can change. But now once these values are available to you, you can process it. So then once again begin, and then I will be writing now for q1. Okay, always you remember, because q1 I have not written, q0 I have completed, but q1 I have not done. So you can think of this thing, let's say this is your q0, okay, x equal to 1, this is your clock, so this is your q0, but what will be the q1 value, that I have not given. So this program is still pending. Okay, so I am doing it now. So q begin, and as it is asynchronous, that's why I have to write like this. So always you remember, when you are doing for asynchronous, this type of block you have to prepare. So this block output will depend upon, this block output will depend upon the next, next programming or next block. And if you have more number of bit, then another, again this thing you have to process one by one. Okay, because if you have, let us say, more number of flip flop, then the next will be depending upon this output. So this process, what you have to do, once again you have to write the code which will be depending upon the output of from this particular event. Okay, so this is called sequential way of writing the code. Okay, VHDL in inherently parallel architecture, but if you write like this asynchronous way, you have to make sure that it is sequential. So first it will execute it, then it will go to this, and then it will go to this. Okay, so here begin, and then again if I will write, if rising edge, so there is nothing problem in rising edge. Okay, so let me write it. Okay, so let us say this is the rising edge. Okay, or clock. So if fast, fast event, whatever it completed, let us say 1 2 3, this 3 clock, the clock event complete, then what will happen, then the next one, the rising edge, okay. So from the next bit, this one will start from here, okay, the next rising edge. So clock is going on, but the next event, so execution of the particular second particular flip flop will start from this particular clock event, okay. Before that, the previous flip flop was executed. As you know that q0, q1, q2, these things are happening. Then once this process is complete, then you can start from the next particular flip flop event, okay. So this is called kind of synchronous way of sorry, asynchronous way of writing the code, okay. So there is no problem if you write the rising edge, okay. So if rising edge, and then you tell me then what rising edge I will consider here. This is very important, whether I will consider clock or what value I will consider. See that q0 is a variable I have taken now, because process q0 means 0, then 1, then 0, then 1, okay. So this event I will take or consider, and based on that I will now assign the value. So therefore I will consider the rising edge of this variable itself, okay, not clock. Clock already control the first flip flop, but clock do not control the second flip flop. Okay, second flip flop is controlled by the output of the previous one. Okay, the Q0. So that's why I will write this is the rising edge, and then in that bracket I will write Q of 0. Okay, so you know how to write for asynchronous code now. Okay, in synchronous code you only process clock, but here not only clock. So your first objective is complete, so you have to control using clock. Then next is the variable which is output, that should be the process, and then it will execute the operation for the second flip flop. Similarly, if you consider a third flip flop, then the output from the first one or second one, that will be a process, and this will control the output of the third one. Okay, so this will be continuous process, so it's kind of a cascading program. Then next is then it is okay. So here I will write if x again equal to 1, then only I will change. Then q1, now here it is interesting. So what I will write, q1 will be what? So let me write. So 0 0 is the state, 0 1, then 1 0, then 1 1, okay. And you are taking this as a process variable. Okay, so you tell me that whenever there is a change, that means rising edge if you consider. So here 0, then 1, then 0, then 1. Okay, whenever there is a change or rising edge change, then what is happening here? Then you see there is a change in the particular bit. Okay, whenever there is a change, next bit will be 0 0. Okay, that means once again there is a change. So I can see directly that q of 1 is nothing but not of q of 1. Now you can ask me, sir, not of q1, so what is that value? So initial value already you know, that initial value I have taken as 0. Okay, when I declare that q0 and q1, that is 0 0, that by default means that I have started from 0. So first value you will get 1, so that is the point here. And you can see that the output will change from 0 to 1. This particular event will only happen in this particular position, okay, and the next event will happen in that particular position. So this is q1 equal to not q, that is perfectly fine. Then next is end if. For this particular if, again end if for this for the rising edge, and then end the process. Which process? q0 process. And then end behavioral, because I do not have any kind of, so I am writing for 2 bits, so this 2 bit is complete. So end behavioral. Okay, so this is the code of asynchronous. This is the code for asynchronous. Okay, asynchronous up counter. So what is the learning point? The learning point is similar like the previous one, but one difference here. if you have asynchronous counter, asynchronous means sequential way of writing the code. So first code you have to write, this is for one process. If you complete it, then you next go to the second process. Okay, this is the process 2, and then you have to go for the third process. Okay, so as it is asynchronous, so the clock will not control all the events simultaneously. So clock will control the first event, then the output of the first one will control the output of the second one. Okay, so this is the process intermediate process variable you have to consider. And then here also, if you have more number of flip-flop, then once again you have to consider another variable intermediate here. So first you execute this code, then after that, and this is the next version of the code. So if you do that, then only you can implement the asynchronous up counter. Okay, for 2 bits. So I have written for 2 bit. So you can try for more number of bits. Okay, but the process is quite simple. So do you understand this thing or not?
So I still have doubt in the Q1 part. Like I
Which
didn't
one?
understand. So I did not understand why Q1 is less than equal to not Q1.
Less than equal to. This is a less than equal to sign.
Sorry, sir. My bad.
So Q1 equal to not Q. Why I am writing this?
Yes, sir.
Okay,
So
you
I
see
didn't
the
understand.
event. Okay, to see, you see this event. Okay, so here let us say 0 state, then 1 state, then 2 state, and this is the 3 state. This is the up count. So 0 to 1, 1 to 2, 2 to 3, and then 3 to 0. Okay, you can say that how I am writing this, because it's a 2 bit. So 2 bit means 2 square, basically 4 event. Okay, so 0 1 2 3. Now that can be written like this: 0 0, then there will be 0 1, then 1 0, and then 1 1. So now I have considered there is a lower bit q0 and that is the q1. Okay, so q0 is, let us say, it is controlled by the clock, the first flip flop. If you consider this is the first flip flop, and you see the every event there is a change in the previous one, so it's a not gate. But now if you consider the output, this q, okay, so this q output will control the second flip flop, so this is a process now. So you see that here 0 1, then 0 1. So 0, I'm writing here 0 1 and 0 1, this is the output, and that will be actually controlled by this the clock, and x is the input. So this is the output. Now what I told, as it is asynchronous of asynchronous up counter, then this you have to consider as a process, and based on that the next output will depend. Now you tell me that initial value of q2, let us say this is q1, or I let us say q0, and here q1, let us say. Okay, so what is the initial value of q0? It is 0. So initial value of q0 is 0. Now if it is 0, so 0 will come. So here I am writing, so 0 is coming here, and from here 0 is coming. Okay, and your this clock event actually goes, and then you can see that the output is basically, and next event what will happen, next event it will be, this will be 1, and then what will happen to this will be 0, because you see this is, I have not taken that as a process variable yet. Okay, once it is completed, then you can process. So then once again 0, and then once again 1. So this up to this process is complete. So basically you see 0 1 0 1, that will continue for the first flip flop. Okay, so basically this is the process. Now if you consider the second program, so you have 0 1 0 1, this is the output for the first flip flop. Okay, is 0, there is 1, 0, there is 1. Now this will control the output of the next one. Okay, so whenever you have a transition, okay, from 0 to 1, whenever there is a transition, okay, so that transition, what will be the output? You can see this. Okay, whenever there is a transition, this transition you think, so 0 1, okay, then 1 0, and then what is that, 1 0, sorry, let me write 1 1, okay, and then once again 0 0. Okay, so you see this here, what is the changeover? 0 1, yeah, this point 0 1 this, and here there is equal 1 0. Okay, so Whenever there is a change 1 to 0, there is a change of the q. Whenever there is a change of 1 to 0, there is a change of q. Okay, so that I can write like this. So I have written like the rising edge. So you can write here falling edge. Okay, in the code you can write here falling edge, and why it is so I'm just explaining. Okay, falling underscore edge. It is not rising edge. Okay, I am telling you this why. You see this 1 to 0, okay, there is a change. Then once again 1 to 0, there is a change. So definitely you see 0 to 1, whenever the intermediate variable is changing from 0 to 1, actually q1 is not changing. So this is q0, okay, and q1 is not changing. But q1 is changing here. Whenever there is a 1 to 0, there is a change of q. And similar thing happens here. Whenever there is a change from this position 1 to 0, then there is a change of 1 to 0. So see, the thing is that it is just a NOT gate of the previous one, but the transition is not rising edge. Transition will be for falling edge. Okay, so that modification you have to do. So 1 to 0, here there is a change, and then once again 1 to 0, there is a change. Okay, otherwise it will remain in the same one state. Or if you consider the previous one, so let us say 0 0, you see there is a change, but the same value is persisting. You can see 0 to 1. 0 to 1 means what? Rising edge. But in the rising edge, you see there is no change in the q1. Okay, but however, if you see this thing 1 to 0 falling edge, the output is changing. So in the program, what you have to change here, so I have written rising edge, you have to write falling edge. Okay, then this program is correct. Okay, now it is clear, you understand this.
Yes, sir.
So you see the problem of the asynchronous way of writing the code. Okay, the problem is first this variable or intermediate variable you have to take, and based on that where there is a toggling, that you have to check, then you can write. Again, if you have more number of flip-flop, then this will be the process, next process, and based on that the next output will depend. So there are a lot of propagation delay, and not only the propagation delay, but also you see the timing. Okay, initial clock, if your initial clock is this, so after that the frequency actually reduces, again the intermediate frequency it reduces, and finally when you have more number of flip-flop, the frequency actually reduces. Okay, so this is the problem of writing the asynchronous way of writing the code. Okay, so 1 by 2 to the power n, so n is the number of bit. So if you have f in is the frequency of clock, let us say this is the clock frequency, and the output state means you have a number of up count, and finally you have the output. So output will vary in the frequency of f by 2 to the power n. Okay, so if you are happy with that, then there is no problem. But you see this programming is quite slow, because this is a timing event, and once again this is another timing, so comparatively they keep on slowing the process. Okay, so that's why this kind of programming or sequential way of programming is not good for the FPGA, okay, or VHDL code. But sometimes we cannot avoid it, sometimes we want. Okay, sometimes we want that the second process will only depend upon the execution of the first process. So in that case, definitely you need to use the sequential way of writing the VHDL code. Okay, so I hope you understand this process of writing the up counter using asynchronous manner. Is it clear to you?
Yes, sir.
Okay, so the thing is that this part is over. Okay, now from the next class, I will start advanced topic. Okay, so basic topic is already over. What you need to know for the programming part is already over. So next class, I will be writing practical VHDL code to implement something. Okay, basically power electronics. I will be writing for a pulse width modulation, I will write for SPWM. So these are the application I will write code in VHDL, having this knowledge in your mind. Okay, and first knowledge already I told that, let us say frequency division I want. Your input frequency is 3 megahertz. Suppose I want a 10 kilohertz signal. So can I achieve it from 10 megahertz clock frequency? Can I achieve 10 kilohertz? The answer is yes. By using VHDL code, if you write properly, then you can have a signal of 10 kilohertz frequency. Okay, and 50% duty ratio. That is possible. Okay, so the application part I will just start from next class. Okay, so mostly this module is completed. I will take 2 3 examples using the VHDL. Okay, that examples how to implement, basically practical, maybe 3 4 classes are required. Okay, so to complete this particular module of the syllabus. Okay, so the prerequisite, what is required for VHDL is mostly covered, and now it is time to apply those. Okay, so slowly I will apply onto the real time application. Like I already told that I have given a state machine. Okay, from the state machine, can you write the code? The answer is yes. Now I will do one thing. I will have a real problem statement. From the problem statement, you have to draw the state machine, and then you can write your code in VHDL. Okay, so slowly I will do that. Okay, so today I am stopping here. If you have any question, you can ask.